Okay, let's look at example 4 a little bit more. So we worked out part A together, and I hope you filled in part B. I filled in our addition and multiplication table for this example as well. And so here we have two examples of factorings. And my question is, when you're looking at those two factorings, is either of them an integral domain? Is either of them a field? So what do we need? We need the absence of zero divisors, and then we need inverses, multiplicative inverses for fields. So if you're looking at our example z mod 3z, you will see that no zero divisors. If you're looking at the multiplication table right here, no zero divisors. And we do have inverses. Yep, we do have inverses. We see that 1 plus 3z is its own inverse, and 2 plus 3z is its own inverse. So we have multiplicative inverses. So we do have units. So 3z mod 3z is an integral domain, and it's a field. So z mod 3z is an integral domain. And also, or furthermore, so it's a field. What about z mod 4z? So if we are looking at our multiplication table right here, do we have zero divisors? So the zero element in z mod 3z would be 4z. So 4z is the zero element. And do we see that somewhere, even when we're multiplying together non-zero elements? And yeah, actually here it is, right there. So 2 plus 4z looks like it's a zero divisor. So, so this is neither, because 2 plus 4z is a zero divisor. So what's the difference between the two? Well, 3z was a maximal ideal, and it's also a prime ideal. And 4z is not. It's not prime, it's not maximal. And those are the two things that make a big difference. So this is an observation that it's worth writing down. So 3z is prime and maximal as an ideal, and 4z is neither. Neither prime nor maximal. And it turns out that a prime ideal will guarantee that your factoring is an integral domain, and a maximal ideal will guarantee that your factoring is a field. So we have theorem 14.3 and 14.4, and they say that if you have a commutative ring R with unity and you have an ideal A of R, then R mod A is an integral domain if and only if A is prime. And R mod A is a field if and only if A is maximal. So here we are. Two important